Hi guys, my name is Lucas and I'm going to introduce to you a few questions that are asked in Java interviews in English from big techs, alright? And in this first video I'm going to introduce to you some foundational questions that they use to ask, okay? So let's go. What is object-oriented programming? Is a programming paradigm based on the concept of objects which can contain data and code, and instead of viewing a program as a list of instructions, which is a procedural programming, OOP views it as a list of interacting objects. Okay? The main goal is to bind the data and the functions that operate on them together so that no other part of the code can access this data except that function. And the object-oriented programming has four pillars: abstraction, encapsulation, inheritance, and polymorphism. Only this answer is enough, okay? The interviewer will maybe ask to you to define all the four pillars, and if he asks you, then you will answer, and we are going depth in these four pillars right now. Abstraction: hiding the complex implementation details and showing only the necessary features of an object. In Java, we achieve this by using abstract classes 0 to 100% of abstraction and interfaces 100% of abstraction. Abstract classes, of course, can have concrete methods, so you won't have always 100% of abstraction, okay? And it helps reducing code complexity, improving security, and allowing for loose coupling between systems. Encapsulation is one of the fundamental principles of object-oriented programming in Java. It is the concept of wrapping the data and code together as a single unit and restricting direct access to some of the object's components, which can prevent the accidental modification of data. Okay? Example: entities. You will declare your attributes as private and will retrieve the value using the getter method and the setter method. For example, in a bank account you have a balance attribute. You will need some validation to change the balance, to make a transfer, okay, and to see if the account is still active. So you can add validations only using methods and not, and if you change the value using the attribute, it will lead to vulnerabilities. So the purpose of encapsulation is to protect the data, all right? Inheritance is a mechanism where one class acquires the properties and behaviors of another class, enables polymorphism, allowing specialized behavior in child class. For example, using the extends keyword, you can only extend one class in Java, okay? And if a plane extends vehicle, for example, the plane will automatically inherit methods like the start engine and stop engine and add its own method called takeoff, for example, because not every vehicle take off, okay? Polymorphism allows objects to be treated as instances of their parent classes rather than their actual class, enables methods to perform differently based on the object that it is acting upon, thus enhancing flexibility and reusability. Okay, one example, classic example of polymorphism is the list, okay, which is an interface being instantiated using an array list, and the method add in list will behave like it is implemented in the array list. If you use a linked list, for example, the add method will behave differently, okay? And there are two types of polymorphism: using compile time polymorphism, using method overloading, methods of the same name but different arguments, different parameters, and runtime polymorphism, which is method overriding, methods where a subclass provides a specific implementation of a method that is already defined in its superclass. Okay, and method overriding are methods of the same name and same signature. Okay, and the method that will get executed will be determined at runtime based on the object's actual type. Okay, what is a class? Simple. User-defined data type that encapsulates data and behavior into a single unit. We talked a bit about data and behavior in other definitions in those slides. Abstract classes. They are designed to serve as blueprints or templates for other classes. They define common features and behaviors that subclasses will inherit and potentially implement in their own specific ways. Can contain both abstract and concrete methods, variables of any visibility with those four access modifiers like private, protected, public, or package private, for example, and is a relationship, right? That will be more than enough. Interface defines a contract or a set of capabilities that a class can promise to fulfill. Again, it's used to achieve polymorphism and define behaviors that can be shared across disparate classes. Is the type of relationship a has a and can do. One example, for example, is the functional interface runnable, alright, that we must implement to use to create our threads, alright. Other important question: why a string is immutable? Strings are frequently used in secure sensitive operations, okay, like file paths, network connections, database credentials, and if they were mutable, a malicious actor could potentially alter these values after they have been validated, leading to security vulnerabilities. Immutability means that once a string is validated, its value will remain constant. Okay, and they are thread safe because immutability is thread safe. If a class is immutable, once it is defined, it can't be modified anymore. Caching in the string pool. Okay, you must activate. Java uses a string pool to optimize memory usage by storing unique string literals. When you create a string, okay, the JVM will check if an identical string already exists in the pool. If exists, the JVM will use that reference, won't create another string in the pool in memory, okay? What is an unmodifiable collection? An unmodifiable collection is a read-only view or wrapper around an existing, potentially mutable collection. Okay, it prevents direct modification through the unmodified reference itself. Okay, if you create the unmodifiable collection here, okay, and the underlying collection can still be modified by other reference that hold a direct pointer to it. So you can change this mutable list, and if you reference using the unmodifiable collection, you will get the value that changed here, and you will print the cherry, for example. So you still can change the underlying collection, and these changes will be reflected in the unmodifiable collection itself if you change the underlying collection, right? An immutable collection, once created, cannot be changed in any way, right? It's a self-contained entity that holds its elements and does not reflect changes from any other source. Okay, so for example here, if you try to change this using these methods like list of, if you add something to the list, will throw unsupported operation exception. If you create a list, an immutable list based in an underlying collection, alright, like this mutable list, if you change the mutable list, this change won't be reflected. Why? Because normally these methods make defensive copies of the list, so they won't hold a reference to the underlying collection itself, okay? Other frequent asked questions. What is JDK? It's a comprehensive software package for developing Java applications. It includes everything needed to write, compile, debug, and run Java programs. Okay, it includes the JRE, the JVM, debuggers like JDB, okay, JavaDoc, etc. Alright. JRE is the Java runtime environment, the software package that provides the minimum requirements for running Java applications. Okay, does not include development tools like the compiler, for example, right? And consists of the JVM, the core component that executes Java bytecode, and Java class libraries, that is a set of pre-written classes and interfaces that provide common functionalities for Java applications. The JVM is an abstract computing machine that enables Java bytecode to run on any platform. This is the core concept of Java platform: write once, run anywhere. And of course, the primary function is to interpret and execute Java bytecode, and can be divided into three main subtypes. The class loader, right, executes, for example, the static initializers and static blocks on the class, because when the static members of a class are only executed once, the class is loaded, alright, by the JVM. The runtime data areas, which have the method area, the heap, stack, and PC registers, in the executing engine. Okay, so we are going to talk a little bit more in depth now about the heap and stack, okay, and the garbage collector too, right? So summarizing, if you answer that the JVM is the abstract computing machine that enables Java bytecode to run on any platform, that is the core concept of Java platform: write once, run anywhere, and can be divided in the class load, the runtime data areas, and executing engine. I guess that it is enough. Okay. And of course, they will ask what are the three main subsystems in more in depth. So, but I think normally they ask separately, right? The heap, for example, they ask this a lot: the heap, the stack, and the garbage collector. The heap is where all objects and their corresponding instance variables are stored, shared resource among all threads in a Java application. And the garbage collector is responsible for automatically reclaiming memory from objects in the heap that are no longer referenced or reachable by the application. Okay, so we are going to explain a little more how the garbage collector behaves, but is where all the object and their objects and instance variables. Memorize this, alright? Because now we are going to talk about the stack, and many interviewers ask you the difference between the heap and the stack, okay? So the heap is where all objects and their corresponding instance variables are stored, and that it is a shared resource among all threads in a Java application. And the garbage collector is responsible for automatically reclaiming memory from objects in the heap. Okay. The stack is way different, right? Each thread in a Java application has its own dedicated stack memory. Okay. use it to store local variables, method parameters, and method call information, the stack frames, okay? So the memory is allocated and deallocated automatically as methods are called and returned, making faster than heap allocation, of course, because once those methods are called and returned, the stack is finished, right? How garbage collector works internally. Internally, the garbage collector have two generations, right? The young generation and the old generation, okay? And in the young generation, the young generation is divided in three subspaces. The hidden space, which is the initial birthplace of an object, okay? When the object is created, it is moved to the hidden space, and when the hidden fills up, all right, the space fills up, a minor garbage collection is triggered. If the object is not referenced or used anymore, the object is finished. The object dies, okay, liberating space, of course. But if the object has survived, he is moved to the survivor space, okay? And when it is moved to the survivor space, there are two spaces, and when the first one of the spaces fills up, the garbage collector will make a minor GC, okay? And if the object survives, the object will move to the other survivor space, and the object will be moving from minor GC to one survivor space to another until a certain number of minor GC is reached, and when this number is reached, if the object are still surviving, he will be moved to the old generation, used for long-lived objects, and there are objects that have survived many rounds of minor GCs in the young generation, generally more used by caching objects, connection pools, singleton objects, like those beans on Spring Boot, for example. Singleton, generally speaking, but those beans, for example, would be a good example, right? And when this space fills up, a major garbage collection occurs, which is usually much slower and involves the stop of the world pauses. Stop the world pauses. Stop all threads in the application when a GC, a garbage collection, is realized. So that's the reason why the young generation is used first, because the young generation occupies, I think, 1/3 of the space in memory for garbage collection, and the old generation occupies 2/3, okay? And we reached the end of this video, so I intend to make more videos for you soon about, for example, how sets like hash set, hash map work internally. So for now I'll keep this video short, and this is the end. And if you have some message to send to me, send to this email. My English is not that good, so I'm making these videos exactly to practice more and show more content to you. Okay,